Welcome to the white box testing guide. It might surprise you to know that this method is not as widely utilized as you might expect. So this lesson will help you get ahead of the game by adding this skill to your test toolkit. White box testing involves examining the internal structure of software, requiring a good understanding of the code to verify paths, loops, and data flow within the application. It requires specific skills, which is why it's not as commonly used as many other test techniques, but you can learn the basics here. Let's get started. White box testing focuses on several key aspects. Code coverage ensures all possible paths of the code are tested, including conditional loops, statements, and functions. Data flow testing focuses on the various paths that data takes through the program and checks for anomalies, such as unused variables. Control flow testing verifies the logical flow of the program through different branches, whereas security testing identifies vulnerabilities in the internal code that could be exploited. Each method ensures that the software's internal workings are thoroughly examined for potential issues and vulnerabilities. Let's explore an example using some code that was written to support a satellite TV order management system. The function under test calculates the total order price. This is calculated by summing up the base price, the number of channels, the addition of the premium package, and whether the DVR service is provided. DVR is an abbreviation for a new digital video broadcasting service. These items can showcase how different conditions can affect the final cost. Here is the code under test. Analyzing the structure involves understanding how the function adjusts the total price. It uses conditional branches to add cost for extra channels. It will also use the conditional branches if the premium package is selected, and DVR services are utilized. As testers, you need to ensure each path is tested for accuracy. You need to consider various test cases: a basic package with no extras, a package with extra channels, and combinations of premium and DVR services. Each scenario helps verify the function's ability to handle different pricing conditions. Let's go back to our code and see how you are likely to build your test cases. The function starts with a base price, but the final total could be recalculated based on the number of channels, whether the customer selected a premium package, and if they opted for a DVR service. The next part of this video is mainly focused on working through 5 test cases. So this may be a good time to grab a drink and be ready to pause the lesson. You may need to think about the example test cases and how they relate to the code. If this is your first rodeo on white box testing, take your time. We all started somewhere. If you are experienced in this type of testing, this should be a walk in the park for you. Let's get started with the 5 test cases. They all use different paths through the code, and this will be mapped for you so you can see where this is going. Test case 1 is a basic package with no extras. The test cost calculator may look like this. But what does it mean? The first item relates to the base price, and that is fixed at $100. The second item relates to the number of channels, and it's 100 in this instance. The logic in the code says that the price calculation for extra channels will only happen if the number of channels is greater than 100, so there's nothing to add. The third item relates to the premium package. The value is false for this, so there's nothing to add to the base price. The final condition relates to DVR service. This is also false, so once again there's nothing to add. The path through the code is quite simple in this instance, as only the base price is applied. The code not utilized has also been grayed out, as none of these conditions is applicable to the test case. The test case can be written with this fairly simple description and shows the expected result, which in the case of this scenario is a total cost of $100. Now we can look at some more test cases and start mapping their path through the code. Test case 2 is a basic package with 50 additional channels. And here is the test calculation. You may have noticed there are now 150 channels included in the cost calculation. That's 100 in the base price plus 50 additional channels. At $2 per channel, the cost is now an extra $100. There is still no premium package or DVR, so these are ignored. Therefore, the total cost is $200. The path taken through the code looks like this, and the rest of the code is ignored as the remaining conditions still have the value of false. Finally, we add the test case description, and this will include the expected result for the total cost, which is $200. Let's move on to test case 3. Test case 3 is a basic package with premium, but no additional channels or DVR. And here is the test detail. The change to note here is that only the premium service is being added to the base package, and that's a cost of $50, and the total cost should be $150. The path taken through the code looks like this, and the rest of the code is ignored as it doesn't apply in this scenario. And of course, you would add the expected result of $150 in the test case description. Before we start the next test, it's worth mentioning that you shouldn't get hung up on test case format, as there are multiple ways you could write them. The important takeaway here is making sure you can identify multiple paths through the code to prove it supports the full range of requirements whilst also being error-free. The pricing code is likely to be called by multiple functions, so it has to be robust and reliable. Let's start the next test case. Test case 4 is a basic package with DVR, but no additional channels or premium. This time, we'll look at the path through the code first and ignore any code that is not used. Then we'll reverse engineer the calculation. Based on the previous examples, what do you think the calculation formula will look like? When you write it down, can you also calculate the final price? Pause this video if you need time to think. Hopefully, this is the calculation you came up with. If not, then give yourself a few more moments to think about this. Only DVR is added, so that becomes true. As DVR is the only addition to the base package, we just add $20, so the total price you should have calculated is $120. Here's the description just for completeness. Let's do a last example with a few more options selected. Test case 5 is the full package. This consists of the basic package with 50 additional channels, premium, and DVR service. As we walk through the test calculations, we'll also build a picture of the path through the code. As with any order, there is a base price of $100, but the first thing to note is that 50 additional channels have been added. This exceeds 100 channels, so this piece of code will be exercised. So we can follow that path. Next, the premium service has also been added, and this segment of code will also be activated. Let's see how that affects the flow. Finally, DVR service has been added, and this will activate the last conditional piece of code, which will take the flow through to the total price. To finish the test, let's add the description. You may have noticed that this includes some details on how we calculated the total cost of $270. How you document your tests may be determined by standards used in your test team, but the important skill is ensuring you have enough test coverage. I am sure there are plenty of other tests you may have spotted. To make sure your coverage is good, boundary testing is crucial, and we have highlighted some code where boundary tests can be applied. To test the boundaries, write a test with exactly 100 channels. This will ensure there are no extra charges for additional channels. Also write another case with just one extra channel to verify the correct pricing. These tests will help to confirm the function's reliability under different conditions. We also analyzed potential security vulnerabilities in the calculate order function and made some observations you may have noticed yourself. The first thing we noticed was a lack of input validation. The function assumes that the inputs of base price, number of channels, premium service, and DVR service are all valid. However, there is no validation on these inputs, which could lead to security risks or logical errors. There is a risk that an attacker might pass negative values or non-integer values for the number of channels, which can lead to incorrect calculations and crashes. To mitigate this risk, validation needs to be introduced to ensure that base price and number of channels are non-negative numbers, and the premium service and DVR options are booleans. We made a few other observations on the same code. Firstly, there is a business logic issue in the number of channels code. It doesn't impose a cap or limit on the number of channels, allowing a user to input a massive number, leading to unreasonable costs. The code needs to impose an upper limit on this, then handle scenarios where the value exceeds that limit. There may also be a floating point precision issue when calculating the total price. If the base price is a floating point number, rounding errors could accumulate, leading to slight discrepancies in the price. This could be addressed by ensuring that calculations involving prices use fixed point arithmetic or round the result to a suitable precision, such as 2 decimal places. To wrap things up, we will look at a new extract of code where we identified a loop error. Let's make this more fun by making the code an automated countdown to launch a rocket. In this simple example, the while loop condition means the loop should continue as long as the count is greater than 0. Let's explain the error. There is no decrement statement inside the loop to reduce the value of the count, meaning the loop will never end once it starts. This causes an infinite loop, and at best it would be an embarrassment. At worst, the rocket launch is delayed. Here is the corrected version of the code. The corrected version includes a count statement inside the loop is highlighted. This ensures that the count decreases by 1 on each iteration, eventually reaching 0 and exiting the loop. Once the loop ends, the program prints liftoff to indicate that the countdown is complete. Let's see how the countdown looks now. 5, 4, 3, 2, 1. Liftoff. A successful test. In summary, you should now have a basic understanding of white box testing, including code coverage, data flow, control flow, and security testing. By understanding the code, your test skills will multiply and your ability to handle scenarios effectively will be enhanced. This method of testing also helps to impress in interviews as it's not a common skill. If this is all new to you, now would be a good time to speak with a friendly developer on your project and see if there's any code they can share with you. Practice makes perfect. I'll see you on the next lesson. If you found this useful or just enjoyed watching, then like this video and subscribe to our YouTube channel so you can keep updating your skills. To see more videos with advanced testing techniques, click on the link in the description below. This will take you directly to my YouTube playlist. We have organized the lessons into a logical viewing order so you don't have to. Stay tuned so you don't miss out.